Welcome to our episode on condensing and expanding logarithms. What we're going to look over condensing, which basically means taking multiple log equations and condensing or combining them into one. And we're going to look at expanding, which is the opposite, where you take one log equation and expand it or kind of divide it into multiple log equations. So before we get started, you will need to know these rules. These rules are the equality rule, the power rule, the quotient rule, and the product rule. All of these are very important, and in order to get through this video, you're going to need to know them by memory. If you need more info on them, we made a whole video about them with examples and stuff. So if you still struggle with that, you can check out the video. So now on our first example, it's going to be 3 times log of a minus 2 times log of k. Now, before we get started, I want to make sure that a and k are not the basis of these two logs, but rather the argument. And instead, this is log base 10, which is usually just written as log. And before we move on, I want to point out that the logs have to be equal in order for this to work. What you want to do in this example as a way to condense it, you want to take the 3 and using the power rule, you want to take that number and put it as the exponent of the argument. So what's that basically going to equal is log of a to the power of 3 minus log of k to the power of 2. And if we condense it even further, we can take the two subtracting log equations and combine them into one that is dividing. So using the quotient rule, we can basically turn it into log of a to the power of 3 divided by k to the power of 2. And that's your final answer. Moving on to our second example, we have log of b plus 8 times log of d. Now, in order to condense this, we are going to do the same thing where you take 8 and using the power rule, we are going to turn that into the exponent of d. So that's essentially going to equal log b plus log d to the power of 8. And if you want to condense it even further, what you have to do this time, you're going to use the product rule where you turn log equations that are adding and you combine them into one that has the argument multiplying with each other. And what that's essentially going to equal is log of b times d to the power of 8. And that's your final answer. On our third example, we are gonna expand this time. So instead of kind of trying to make the equation as small as possible, we're gonna try and make it as big as possible because why not? So in order to do this, we have to use the rules we've been using, except in a backwards manner, where this time, instead of having the argument dividing, we are gonna turn that into two equations that are going to be subtracting using the quotient rule. So what that would essentially equal to, it would equal to log of x to the power of 3 minus log of y to the power of 5. And in order to expand it even further, we want to take the exponents of those two numbers and move it to the front using that same power rule, except we're kind of using it backwards. So we take that and turn it into 3 times log of x minus 5 times log of y. And that's your final answer. On our fourth example, we have 3 times log of a minus 2 times log of b. And since we're back to condensing, I want you guys to practice. So pause the video and see if you can condense this equation as far as you possibly can, using the rules that we were given. Welcome back. Now, we're gonna check your answer. So first, what you should have done was move the number in front and turn it into the exponent using the power rule. And what that should have given you was log of a to the power of 3 minus log of b to the power of 2. And if you condense it even further, you should have gotten log of a to the power of 3 divided by log of b to the power of 2 using the quotient rule. And I hope that was your final answer. And it's okay if you didn't get it. It's all just practice. So on our fifth example, we're going to do something different this time. We're going to prove that log of 1/2 is equal to negative log of 2 using the rules that we know. So pause the video if you want to try this problem, but if not, here I'm going to show you how to do it. First, what you're going to do, you're going to actually expand log of 1/2, and that would essentially give you log of 1 minus log of 2 using the quotient rule. And now, using the equality rule this time, we know that log of 1 is equal to 0 because any number that has the argument of 1, or basically any number to the power of 0, equals 1. And we just know that based on the equality rule. And if we turn the log of 1 from the previous equation into a 0, we get 0 minus log of 2, which just equals negative log of 2. So that's how you prove that log of 1/2 is equal to negative log of 2. For our final example, we have log of a to the power of 2 times b to the power of 3 divided by c to the power of 6 times d to the power of 9. And I know this looks scary to even look at, knowing that you have to expand this, but it's a lot easier than what it looks like. If you take the problem by pieces by expanding first the numerator and then expanding the denominator later, you can see that it's a lot easier. So first, if you expand the numerator, you can get 2 times log of a plus 3 times log of b. And if you expand the denominator, you can get 6 times log of c plus 9 times log of d. Except this time you need to put it inside a parentheses, which turns it into a negative because it's on the denominator. And once you got those two, you can combine them into one. And before you write your final answer, you need to write the log before each term, just making sure, because some people make that mistake. But your final answer would be 2 times log of a plus 3 times log of b minus 6 times log of c minus 9 times log of d. And the reason why negative 9 times log of d is negative is because once you remove the parentheses, you have to turn those two into negatives. And that is it for today's episode. Leave a like if you found this video helpful, subscribe to make learning easier, and share to help us grow. And thank you so much for watching.